Hello viewers, welcome you all. In this lecture, I am going to take up the questions from digital electronics, and I am taking only those questions which are related to the topics that I have already covered in my previous lectures, right? So I am taking the questions that are asked in the exam. You can see here. The first question is the truth table for the given circuit. Circuit is given here, right? You can see here the circuit is. Now if you look at the circuit, the output, this is AND gate, this is AND gate, both are AND gate, and this is OR gate, this is NOT gate. So obviously the output of this AND gate is J naught K, and the output of this AND gate is J K. So these two output are going to be applied to OR gate, and we know the output of OR gate is J into K plus J naught K, right? You can see here. Now you can simplify. I have told you in the previous lecture, K is common, so K into J plus J naught. J plus J naught 1, that gives you K into 1, it means it is equal to K. So Q is equal to simply K, right? So you can see here Q is equal to K. Q is equal to K 0 1 0 1, right? So I think C is the correct answer, right? You can check it here. Yes, C is the correct answer, right? So how you have to solve this? You can solve it quickly by using the Boolean laws. Otherwise, you have to write down the truth table and then you have to check all the possibilities. In that way, you can do it, but that will take a lot of time. This is the simplest and fast way to simplify it, right? So C is the correct answer, right? Now I am going to the next question. The question seems to be very easy. The figure 1 and 2, right? These represents respectively. Now figure 1 is clearly a NAND gate, and NOT. This is AND and this is bubble is a NOT. So it is NAND gate, option C, right? And what about this, right? This circuit. Now it is a bubbled OR gate. Bubbled OR gate means A, B, bubbled OR gate. Now here we have to use the De Morgan's theorem, right? So according to De Morgan's second theorem, NAND gate, right? NAND gate is equal to bubbled OR gate. This is De Morgan's second theorem. So it means it is also a NAND gate, right? It is equivalent to NAND gate. So this option, NAND. Otherwise you will find that it is a bubbled OR gate. Where is the bubbled OR gate option? So option is not there. But bubbled OR gate is a NAND gate, and this is also a NAND gate, right? Now NAND gate is equal to, we know very well it is bubbled OR gate, right? And NOR gate is equal to bubbled AND gate, right? This is the first theorem. So if you look at these two figures, then C is the correct answer. This is clearly a NAND gate and this is a bubbled OR gate, that is basically a NAND gate, right? Now the logic expression for the output by of the following circuit. Now you have to look at the different circuit elements. This is NOT gate, this is NOR gate, NAND gate, NOR gate, NOR gate, and this is again a NOT gate. So what is the output of this one? P naught Q. P naught, you can see here, it is simplified already. So you can see here P naught, because NOT gate is applied, plus Q going here, NOR operation is applied, right? And what about it? Q into R naught. Q into R naught, because it is a NAND gate, right? What about it? Now these two inputs are going, output are going to be act as the input for it. So it is a NOR gate. NOR means these two will be added and then NOT operation. So this one here and this one here, and then we have a NOT operation, right? Now for this gate, it is again a NOR gate, right? S is also added, right? So the rest of the things are same. but we will have plus s, and then we will take one more this not operation. Now what about the next? Next is not gate. So what we will do? We will take the not of this not operation. I mean, one more not operation will be there, but these are two operations will get cancelled. We know very well a not is equal to a. So it means these two not operations are going to be cancelled. So we are left with only this, right? And this is here, and this is the correct answer. So A is the correct answer. So again, you simplify it. Otherwise, you will look for two, not operations. So you have to remember it. Then you can write down it, right? So this is again simplified with the help of Boolean laws, right? Now the next question is, which of the following is an incorrect Boolean expression? This one, right? This one we have to check all of them. So P not Q plus PQ. We can take Q common, right? P not plus P, it is Q. Because P not plus P is 1, so 1 into Q, it is all right, it is not wrong. What about it? P plus Q bar plus P plus Q. So we can multiply it, right? It will become P into P plus PQ plus P into Q bar plus Q into Q bar. This is 0, right? This is 1. 0 plus 1, 1, right? And not 0 plus 1, 1. This is not 1, but this is P. Sorry, I was wrong. This is 0. So it becomes P plus P Q plus P Q bar. So again, you can take the P common, right? Here and here, you will get P into Q plus Q bar. That is 1 plus P. So 1 P plus P, that will give you P. So correct answer. It is correct. It is all right. This equation is all right. These two are all right. What about the third one? Third one is P into P plus Q. So obviously again P into P, that will give you P plus P into Q. Now P into P, it is P, right? Into plus P Q. So you will take P common. You will get 1 plus Q. 1 plus Q, 1. So that is right. That should be equal to P, but here it is given a Q. So it means it is wrong. You can see here, right? So this is wrong. Once again, I am saying when you will multiply it, P into P, you will get P into P plus P into Q. P into P, it is P, right? So you will get P plus P Q. You will take P common. You will left with P into 1 plus Q. 1 plus Q is 1. So P into 1 P. So this is wrong. So this is the wrong option. So there is no need to go for it because the correct answer is already detected, right? So C is the correct answer, right? Now I'm going for it. Consider the following truth table. You are given a truth table, right? And that has 3 inputs and 1 output. The logic expression for F is, now you can see here the solution, they have solved it, but the solution is, they have found the solution by using, Karnaugh map simplification method, right? So actually you haven't gone through that, and I even have not explained what are the Karnaugh maps. So I'm not going into it, but you can simply, do it by, applying the basic Boolean logic. So you can see here in the truth table, they are asking that this F is equal to, F is equal to which of these expressions, right? So if F is 1 here, A, B, C are 0. If I put 0, 0, 0, it means it will be 0. So it means this option is wrong, right? What about it? B option. B option is only C is 1, right? Only C is 1. C is 1, so here it becomes 0, right? C not. So it is 0, C is 1, so it is, what about B? They are 0. So it is 1 into 1, 1, right? What about it? A not B. They are, A not means 1 into 0, it is 0. So it is 1, right? So it means it should be 1 here, right? So it is again wrong. B is wrong. Similarly, you can check C, right? So then you will check D, although you have to spend some time, but even Karnaugh map simplification will also take some time, right? But in this way, when you will check C, you will find that C is also wrong. So you will be reach that option D, and when you will put the values in this expression, you will find that this expression is obeying this truth table. So D is the correct answer. So you can solve it by using this way also. This is the Karnaugh map simplification. I want to tell you one thing, that in Karnaugh maps, if B have a pair of two ones, they are taking the pair of two ones, right? It is called a pair. Sometimes it is asked that the group of two ones is known as a pair, quad or octet. They can ask you. So group of two ones, whether they are horizontally adjacent to each other or vertically adjacent to each other, they are known as a pair. But if we have a group of four ones, right, like 1 1 1 1 or 1 1 1 1 or 1 1 1 1, these all groups, they are known as a quad, QUAD in Karnaugh map. If we have a group of 8 ones, right, that is known as a octet, right? So pair, quad and octet, right? So these are three terms associated with Karnaugh maps. So if you are asked what is pair, what is quad and what is octet in Karnaugh map, then you can answer it, right? Now I am going to the next question. You can see here, which of the following circuit does not satisfy the Boolean expression, this one. I mean, in all these circuits, the final Boolean expression is f is equal to a b naught plus a naught b. So let's look at this option, a b, and b is already not bubbled here. So the output will be a into b naught. And what about this? It is a plus a naught b. Plus means because we are taking OR operation. So f is equal to this already, there is no problem. So it is satisfying this expression. What about the second one, b? Right, b you can write here, it is a plus b, right? What about it? A dot b naught, right? And they are taking the AND operation. So f is equal to a plus b into a dot b naught. Now we have to simplify this expression, this one, by using the Boolean laws. You can see here, it is written here, a plus b into a b naught. Now a b naught is what? It is NAND gate. So NAND gate is equal to bubbled OR gate, right? This is the way. Otherwise, if you multiply it, you won't be able to solve it. So we have to expand it. I mean, a b naught can be written as a naught plus b naught, bubbled OR gate. In that way, it will become very easy, because when you will multiply, it will become a into a bar plus a into b bar plus b into a bar plus b into b bar. So these 0, right? You are left with the a into b naught plus b into a naught. So this is again the same thing that they are saying, right? So it means this circuit is also satisfying this, right? Now let's come to the third option. Third option is a plus b, and what about it? A naught plus b naught, bubbled OR gate. And what about here? A plus b into a naught plus b naught, right? A plus b into a naught b naught. So we have already solved it here. So again you will get, when you will multiply it, you will get the same thing, right? It means this is also obeying this Boolean expression. So it means already in the option is detected, D is not satisfying. So D is the correct answer. You can also find it. They have written here. You can see here, it will become A, B and A naught, B naught, right? And this is it will give you A, B plus A into B naught. This is bubbled AND gate. Bubbled AND gate, now you can't solve it, right? If you put A, B plus bubbled AND gate, NOR gate, NOR A plus B. No, you can see here that even then you are not able to solve this expression, because they are can't be solved because there is an AND operation on the sum. So I can't, further simplify it. So this is the correct answer. This is not satisfying this Boolean equation or Boolean expression, right? Now I'm going to the next question. You can see here the Boolean expression P plus P naught Q, where P and Q are the inputs of the circuit, represent the following logic gate, right? Now you can draw the truth table, right? That which is the PQ and P plus. So you can see here the truth table, right? It is 0, 1, 1, 1. So this is what? This is basically OR operation, right? OR operation between P and Q, right? So OR operation is the correct answer, because you can see OR means P plus Q. So 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1, right? So this is the correct answer. So this is the next question. I'm going to the next question now. You can see the next question. The question is, which of the following circuit represent the Boolean expression? It is given here, right? Now, this circuit is, this expression is a complex expression. So I have to simplify it. Now, it is basically a AND NOT operation on OR, right? I can say that it is a NOR of which, let this component is a and this component is a B. Then A plus B NOT, right? You can see here NOT operation. So NOR means bubbled AND gate, right? This one. So bubbled AND gate, what is A? A is a P plus Q R NOT. This is A, right? And it will have one more NOT operation into B NOT. B is Q NOT P whole NOT, and we will take one more NOT of the whole, right? So now when you will look at it, two NOTs are there, they will cancel out. I will left with P plus Q R, right? What about it? Two NOT cancel out, Q NOT P. So I am left with the P plus Q R into Q NOT P. So when I will multiply it with, so P into P, P. So P into Q naught plus Q into Q bar 0. So the second term will become 0. So I will be left with the P into Q naught. So this is the final solution of this Boolean expression. What I used the De Morgan's first theorem. NOR gate is equal to bubbled AND gate. You can see here. So now let's look at the options. Now it is what? It is S is equal to, it is NAND gate, P Q naught. So this is wrong, right? Not. What about this P Q naught? S is equal to P Q naught. So this is the correct. This is matching this. So this is the correct option. B is the correct option, right? You can even check it. This is P plus Q, right? And this one P plus Q, right? Into R naught and whole term NOR. Sorry, not, it is wrong. AND operation is there only. So I think I mistaken. I will have only R operation. So sorry, AND operation. So this is coming from here and this is coming from here, R naught. So P plus Q and R naught. So this is actually not equal to the option that we are looking for. So this is dropped. This is similarly dropped. B is the correct answer. So this is the way of solving these questions. So I have taken the questions related to the Boolean laws and simplification of Boolean expression that I told you in my previous lecture. That usually question is asked from simplifying a Boolean expression. So the two theorems, De Morgan's first theorem, second theorems, and there are a few Boolean laws that we should have to remember in order to solve these questions, right? So thank you very much.